All right, today we're pulling back the curtain on flight simulators. We're going to go under the hood to look at the incredible open source engine that actually gives digital aircraft their wings, a piece of software called JSBim. You know, when you're using a flight sim, doesn't matter if it's a game or a multi-million-dollar professional trainer, have you ever really thought about what's going on behind the scenes? What's making that plane feel right? What's calculating the jolt when the wheels touch down, or that little shudder you get right before a stall? Well, I can tell you it's not just the pretty graphics. Nope, the real secret is a complex, totally invisible physics engine, kind of like a digital brain that's running thousands of calculations a second, figuring out exactly how the plane should react to every little thing. And that digital brain, that's what we're talking about today. It's the real ghost in the machine, the thing that breathes life into these virtual aircraft. So what do we call this brain? Well, in the biz, it's known as a flight dynamics model, or FDM for short. And the best way to think about it is as the digital DNA of an airplane. It's the code that holds all the secrets to how a specific aircraft is supposed to fly. Its weight, its balance, how the air moves over the wings, everything. It's what makes a huge jumbo jet feel heavy and a fighter jet feel incredibly responsive. Okay, so now that we know what an FDM is, let's zero in on one of the most important and widely used FDMs out there, JSBsim. So, what exactly is JSBsim? Well, for starters, it's been around since 1996. I mean, that's practically ancient in software years, right? And it's open source, which is a huge deal. It means its code is totally free for anyone to look at, use, and even improve. It's written in a powerful language called C++, so it's super fast, and it runs on pretty much any computer you could think of. But its real magic is its flexibility. It can power a real-time simulator for a pilot to fly, or it can run away faster than real-time to just crunch massive amounts of data for engineers. And this wasn't cooked up by one person in a dark room. No way. The creators themselves are really clear about this. The strength of JSBsim comes from this massive global effort that's been going on for decades. I mean, just look at who is building this thing. It's like the Avengers of aerospace. You've got actual aerospace engineers, military and commercial pilots with thousands of hours in the real cockpit, brilliant mathematicians, computer scientists, and even researchers from NASA and university students. It's that incredible mix of brains and real-world experience that makes the simulation so deep and so realistic. So how does a team like that actually build a digital airplane? How do you translate a real physical hunk of metal into lines of code? Well, it's probably a lot more straightforward than you'd imagine. See, the secret sauce here is that JSBsim is completely data-driven. What that means is you don't have to be some coding genius to define an aircraft. Instead, you just create a simple text file. Think of it like a digital blueprint, or maybe a recipe that just lists out all the plane's characteristics. And putting this blueprint together feels kind of like assembling a model kit, but with data. You start with the basics. How big is it? What's the wingspan? Then you define its weight and where its center of gravity is. After that, you bolt on the engines and the fuel tanks. Then comes the tricky part, describing how air flows over every surface. And finally, you tell it how to act on the ground, the landing gear, the brakes, all of it. Every single one of these steps just adds another layer of realism. And check this side. This is what a piece of that blueprint actually looks like. See, it's not scary code. It's surprisingly easy to read, isn't it? It's just telling JSBim, hey, the wingspan is 35.8 feet. The entire digital airplane is built from thousands of these simple descriptive lines. Okay, so we've got our digital blueprint all filled out. Now for the really cool part, how does JSBsim take all that data and actually, make the plane fly? Deep down, JSBsim is a number-crunching beast. Every single millisecond, it's solving the fundamental laws of physics. It's constantly calculating those four forces you learned about in school: lift, weight, thrust, and drag. To get this right, it uses a really clever technique. It's got a fancy name, the coefficient buildup method. But the idea is actually pretty simple. Instead of trying to calculate the forces on the airplane as one single object, it breaks it down. It calculates the forces on each little piece, the wings, the tail, the rudder, the flaps, and then just adds them all up to get the total picture. And you can see how it all comes together here. Your wings are making lift and drag. But then, what if the pilot lowers the flaps to land? Boom! JSBsim instantly adds in the extra lift and drag from the flaps. The pilot pulls back on the stick? Okay. Now it's calculating the forces from the elevator to make the plane's nose pitch up. Every single move you make creates a new math problem that JSBsim solves instantly to figure out where the plane is going to go next. Now, I know this is all pretty technical, but here's why it's so incredibly important. This isn't just an academic toy or something for gamers. JSBsim is out there in the real world, doing some seriously vital, life-saving work. Take drones, for instance. Before a real drone like the Echo Hawk UAV ever leaves the ground, engineers literally plug its brain, its real flight control computer, into a simulation running JSBsim. The software then fools the drone's hardware into thinking it's actually flying, letting them test every possible emergency scenario safely in the lab. It's also being used to design brand new, cutting-edge aircraft. When DuPont Aerospace was creating a radical new jet that could take off vertically, how do you think they trained the test pilots? They didn't just toss them the keys and wish them luck. Nope, they used JSBim to build a perfect digital copy, letting pilots master the jet's unique handling before the real one was even built. And the impact gets even bigger. This isn't just about one plane at a time. It's about making the entire sky safer for all of us. An organization called Maitre uses JSBsim to run thousands and thousands of simulations, studying how different planes behave when they're landing. This helps them design safer, more efficient procedures for air traffic controllers all over the world. And of course, it is an absolute powerhouse for university research. At the University of Naples, JSBsim is the literal heart of their advanced motion-based simulator. They put pilots and drivers into really intense scenarios to study how humans react to risk, all to push the boundaries of safety. So when you zoom all the way out from all the code and all the math, what's the big picture here? What does a project like JSBsim really tell us? Well, it tells a story about legacy and endurance. I mean, think about it. 1996. This project has been growing and getting better for nearly 3 decades, constantly improved by a passionate community from all over the globe. It's a perfect example of how powerful, open, collaborative work can be. And that really leaves us with one last big question to think about. What happens when the incredibly complex tools you need to simulate reality, to build these detailed digital worlds, are no longer locked away? What happens when they're open and available to absolutely everyone, from a student in a dorm room to an engineer at NASA? What does that mean for the future of, well, everything? Aviation, engineering, even entertainment. What new worlds are we all going to build together?